Hello and welcome, my name is Amir, and in this video we are going to solve another puzzle from the Codewars website. Okay, so we have selected 5KYU as difficulty, and the first thing that we get is the maximum subarray sum. Let's go and see. The maximum sum subarray problem consists in finding the maximum sum of a contiguous subsequence in an array or list of integers. Okay, so if we have this, we would need to find a sub array. So for example, something like this. I'm just providing something here, which provides the maximum sum that is available in this array. Obviously, if all the elements are positive, the maximum number is the total sum of all of these. But we would have some negative numbers here as well. So for example, here it would be this, as said here. 4 plus 2 is 6, and the maximum is 6. Okay, easy case is when the list is made up of only positive numbers and the maximum sum is the sum of the whole array, as I described. If the list is made up of only negative numbers, return 0 instead. Okay, so if all of these are negative, we should return 0. Okay, it would be nice if you pause the video here and try to solve the problem by yourself. Otherwise, join me in finding the solution for this puzzle. Okay, I will press train here. I would grab this and use it here. I would say const. Alright, so the way that I'm going to attack this problem is have two variables, and as I'm going from left to right, I would keep track of the max sum that I have already found. Okay, so let me give you an example here. So suppose that we have this array of items 1, 3, minus 2, and 1. It's obvious that the 1 and 3, which would add to 4, provide the largest sum, because if I have like all of this, it would be 3, and if I have these two, it would be 1, and so forth and so on. So these two together will provide the maximum sum. Okay, how we're going to solve this? First, I would have a partial sum, which is 0, and the max sum, and the max found, or max sum found, maybe it's better to say max sum found, is also 0, as told here, return 0. Okay, then when I get to a number, so here when I get to 1, I would add this 1 to the partial sum that I already have. And then I would check that if this partial sum is bigger than the max sum that I have found, and in that case I would replace max sum with the partial sum. So let's see. I would get to 1, add 1 to 0, I would get to 1. Now I would compare 1 with 0. Obviously 1 is bigger. So the max sum that I have already found is 1. Then I would move to the next item. It's 3. The partial sum would be 1 plus 3. It would be 4. Is 4 greater than 1? Yes, it is. So the max sum already would be 4. Then I would move to minus 2. I would add 4 to minus 2. I will get to 2. Is 2 greater than 4? No. So the max sum that I have found up to now is 4. Then I would get to 1, add 2 to the 1, it would get me to 3. And the max sum is already 4, and 4 is greater than 3, so we don't change this. So I would get to 4. Let's have another example. Let's have like 4 here. So obviously it should provide the whole array as an answer. So 1 plus 3 is 4, 4 plus 4 is 8, minus 2 is 6. So let's go and see if it works. Okay, I would go to 1, this would become 1, this would become 1, again I would go to 3, the same as before, it would become 4, this would become 4. I would go to minus 2, the partial sum would be 2, I'm not changing this. Then I would go to 4, 4 plus 2 is 6, and the partial sum is 6, it's greater than the 4, so this would be 6, and I'm returning the 6 here. Great. So this should be the answer that I'm providing. So let's go and write it in the code. So I would have two variables. One is the max found, or max sum found. Let's have it max found is 0, and then another one is the partial sum that will start as 0 as well. Now for each of the items that I have in the array, so for let's say item in the array, I would add the partial sum to the item. Now if the partial sum is greater than the max found, then the max found will be the partial sum. Otherwise, nothing. And in the end, I would just return the max found. Okay, this will work as we saw, but if there are like negative numbers that are taking the partial sum below 0, then we should reset the partial sum. So let me give you an example. So for example, suppose that we have like minus 5 here, and this is 2. Obviously now our max sum is still 4, because 4 plus 2 is 6, minus 5 is 1. So this is the biggest that we get. As we would go again, we would get to this, and our sum would be like 4, just like we did it. Then we get to minus 5, and our partial sum would get to minus 1. We don't change, we go to 2, minus 1 plus 2 will get us to 1. But when we get to minus, we need to reset back the partial sum to 2. Why is that? Because if I have, like, for example, this number here, 2, 1, 3, 4, this is going to be the biggest one. But if I don't reset the partial sum, when I get here, the partial sum would be negative, and as it's going to the next item, it will be a negative plus a positive number. So we were here, this was 4, we get to here, this would become minus 1, and as this becomes minus 1, we need to say this is 0. Because if it's minus 1, then I would add it to 2 and 3, and it would get to 4, which is not the correct answer. So when I get to minus 1, I would reset it to 0. Then I would get to 2. The partial sum would be 2 less than 4. I would get to 3. This is 5, and this is 5. 2 plus 3, 5, and this is 5 as well. It's as if when the whole sum becomes negative, it's like if we would truncate those values. I mean, like if we are cutting these values out, but we keep the sum, the maximum sum that we have found. I hope that's clear. So the only thing that we need to do here in the code is just check that if the partial sum goes below 0, we would say that the partial sum is 0. Right? So yeah, I think it's clear. You need to check the code and provide some examples to see the answer. So let's copy and paste and see if it's working. Let's go here, paste, attempt, and yes, it's working fine. So yeah, this was the puzzle for today. I hope you have enjoyed the video, and see you in the next video.